Alright, so let's deal with the first one. Determine the particular solution of d squared x over dt squared. The fact is, you can see there's a square here. That means it has been differentiated twice. You can see the position is d squared x over dt squared. So determine the particular solution. We're going to be substituting values. Right, so now let's write, let me just copy down this question first. So that's d squared x all over dt squared is equal to 4t plus 2. Now, what do we need to do? This has been differentiated twice. That means we need to integrate twice. So from the second derivative, we get to the first derivative. So that will be dx over dt. So we are dealing with direct integration. We don't have to separate anything here. There's only one variable on the right hand side. You can see that. So dx dt, you will integrate 4t plus 2, obviously with respect to t there. Right, so dt means with respect to t. So we integrate that, and that will be 4t squared all over 2. Integrate 2, that will be 2t, and don't forget your constant, we'll put down plus c there. So this is just dx over dt. You're going to simplify it. You can 4 divide by 2, so that's 2t squared plus 2t plus c. Now leave some space here. We're going to be substituting values. Let's do the y. Let's do the x on this side. So from the second derivative, from the first derivative now to the original, we're going to integrate one more time. Right, but I'm going to do it here. You'll see why. So x is equal to, now I need to integrate this. So that will be the integral of 2t squared plus 2t plus c, again with respect to t. So I'll integrate 2t squared, so that will be 2t to the power 3 over 3 plus 2t squared over 2. Integrate c, so that will be ct. And then remember, every time you integrate, you must put your constants. So I'm calling it plus d. You can call it plus e if you want to. The fact is, it's a constant. Right, so you can call this c1 and this c2. So this is your general solution, because we do not know the values of c and d. So it's just a general solution. Now, this question required us to find the particular solution, given that when t is equal to 0, x is equal to 0, and dx over dt is equal to 3. So basically now let's see what's going on here now. So we know this is the first derivative, dx over dt is equal to 3 when t is always, you're only given t once. That means t is equal to 0 will apply here and also apply here too. Right, so now dx over dt is equal to 3. So replace this with 3 when t is equal to 0. So let's substitute the 0 there. So there's my 0 there, 0 there. So, well, this one is an easy one. 3 is equal to c. What else now? When x is equal to 0, t is also equal to 0. Okay, so they gave you 0 here. I don't know why that's 0. It's going to be working out easily, but when x is equal to 0, so there's 0 there in place of x, and then you know t is 0 again. So it doesn't even matter that we found c, because this t is 0. So that means, what is d equal to? 0. D is equal to 0. And now all we do is take this, put it back into, this is your general solution here. Put it back into this here. Here there's 2 and 2 cancel, so that's just t squared. C was 3, so that's plus 3t, and d is 0. You don't have to write down that 0, but you can if you want to. So this is a very simple thing to do. You can see that. Let's work out the next one. Right, our next example, C. So we got the second derivative is equal to 2 minus 3x all squared. Notice I have two methods down on the board here because it all depends now on whether you are going to remove the brackets or not. Okay. So probably most of you would have removed the brackets first, which is correct. So let's deal with that first. So if I remove the brackets before integrating, so this will equal to, so you know if you're removing the brackets, it's going to be a squared, term 1 squared, so that will be 4. To get the middle term, it's 2 times term 1 times term 2. So 2 times 2 is 4 times 3 is 12, so that's going to be minus 12x. And then to get the last term is the last term squared. So minus 3x all squared, that will be a positive 9x squared. And then the rest from here is simple. So I remove the brackets. So now remember, this is your second derivative. So you go from there to the first derivative. And in order to go to the first derivative, you need to integrate one time. So you're integrating 4 minus 12x plus 9x squared with respect to x. And this is equal to, so that will be 4x minus 12x squared over 2 plus, that will be 9x to the power 3 over 3 plus c. So that is my dy over dx. Now I can substitute values here and work out the value of c also, but let me just simplify this first. So that's going to be 4x 12 divided by 2, that's 6 there, and 9 divided by 3, that will be 3x cubed plus c. This is dy over dx. So the information that's given to us is dy over dx is equal to 1. When x is equal to 2, we can find c straight away before we even go to the final, the original equation. So if I do my substitution, dy over dx is equal to 1. So that will be 1 when x is equal to 2. So what do we get? Worked it out already.
Oh, so
So what? This is 2 squared is 4, minus 6 times 4 is minus 24, that's 8 minus 24 is minus 16. And that's 8 times 3 is 24, so minus 16, 24, you get 8 there.
yes, sir.
On the right hand side, 1 minus 8 will be minus 7, so c is equal to minus 7, is that correct? Okay, so c is equal to minus 7. So now, from there, we're going to the original. That is the first derivative, so we're going to go to y now. Okay, I'm going to put the c in now. You'll see that. So y will equal to the integral of 4x minus 6x squared plus 3x to the power 3. And then we just found the c there, which is minus 7. I'm just substituting back here. You're clear with that? It's minus 7. And with respect to x, there's my dx. So now let's integrate. So if I integrate 4x, that will be 4x squared over 2 minus 6x to the power 3 over 3 plus 3x to the power 4 over 4 minus 7x. And if you can call it c again if you want to, if you already have whatever, C, D, as long as you got your constant there. Right, so now this is y. Let me just simplify this here. So this is the general solution at the moment. So 4 divided by 2, there is 2x squared. 6 divided by 3, that's 2x cubed plus 3 over 4 x to the power 4 minus 7x plus d. So what do we know about what's happening here? When y is equal to 1, x is equal to 4. So let's substitute that and see what we get. Y is equal to 1, x is equal to 4. Let me just work out. While you're busy working, I can just double check me. So I've got 4 squared is 16 times 2 is 32. 4 cubed is 64 times minus 2, that's minus 128. This is, what do we get here? It's a high value, that's 64 times 3 there, see? 192?
Yes, sir.
192, yeah. So that's plus 192 minus 28 plus D. And take, you know, now take all this to the left hand side. What do we get there? So D is equal to minus 67.
Yes.
Right, so therefore, the particular or the unique solution. So that's 2x squared minus 2x cubed plus 3 over 4 x to the power 4 minus 7x minus 67. Everybody must get full marks for this question 6 here. You might want to answer question 6 before you answer question 5. There's nothing stopping you from doing that in the exam. You can answer any question as long as you keep all your questions together. Right, so if you start with question 6, you'll start with question 6 on a new page in the exam. And then if you're moving back to question 5, do not start on the same page. You must start on a different page. Okay. Right, so that was method number 2, which you remove the brackets because you saw a square there and you know how to square it. Right. But the question is, what happens if we change this to a 200 now? Okay. If 2 becomes a 200 or a 2000 or something, then we got a problem. So we need another technique can be used here. So remember, now, there's many types that we were dealing with. This is the first type. This is k, and that is f of x to the power n. There's your f of x to the power n here, multiplied by f prime x. This is multiplication, exact derivatives. So you got, if you have f of x, f prime x, the answer is going to be k f of x to the power n plus 1 over n plus 1 plus c. So this applies when you are dealing with multiplication of exact derivatives, only when your n is not equal to minus 1. So as long as this power is not a negative 1 and you have an exact derivative, you can use it. So this is the second derivative, so I'm going to go from here to the first. So I'm going to go there and there is equal to, that means I need to integrate 2 minus 3x all squared with respect to x. Now I'm going to use the method of inspection here because substitution will take too long. But if you've got time, you can do your substitution in the exam. Right, so now I'm going to use the method of inspection. So remember, f of x, f prime x. The derivative of f of x here is 2x, 2 minus 3x. The derivative of 2 minus 3x is 0 minus 3. In order to balance this, remember it was a 1 here. So if I put a minus 3 there, I will divide by minus 3. In other words, multiply by 1 over minus 3. It's the same thing. Now, it satisfies this condition. So therefore, I'm going to go minus 1 over 3, which is my constant. F of x to the power n plus 1, all over n plus 1, plus c, and you're done. Alright, what is your f of x? It is 2 minus 3x. So what is this equal to? Minus 1 over 3 times 3, which is 9. And that's 2 minus 3x to the power 3 plus c. That is my dy over dx. Now, substitute your value. What do we know? Dy over dx is equal to 1 when x is equal to 2. So we got 1 there. Minus 1 over 9. 2 minus 3 times 2 all raised to the power 3 plus c. What is x equal to? 2. So I got, what do I have? 1 is equal to minus 1 over 9. Then I got minus 6. 2 minus 6 here is minus 4 to the power 3. Minus 4 to the power 3 is minus 64. Plus c. You're not going to get the same c value now. Okay, you will not get, because this is written, it's still within brackets. Okay. So you get 64 over 9. So you get minus 55 over 9. So C in this case is minus 55 over 9. Alright, so now let's go and substitute it back. Where is the second derivative? It's here, the first derivative. So what do we know? That dy over dx is equal to minus 1 over 9. And that's 2 minus 3x to the power 3 minus 55 over 9 here. Right. Now, we need to, from the first derivative, we need to integrate one more time there. So this is first derivative from here. Y is equal to, now I'm going to the original, just like what I did here. From where is that second? From the second to the first. So I need to integrate. I'm putting this as a constant, and let me, okay, I'm going to do it in one step over here. Let me separate it. Let me separate this here, because these are two different problems now. So that's minus 1 over 9, 2 minus 3x to the power 3, minus 55. Oh, I won't separate because I don't have space here. But you can see what's going on. Right, so I need to integrate one more time. The fact is, this is the first type we are dealing with, which is multiplication. You can see that. So there's my f prime. I don't have my f prime. Let me just rewrite this here. So that will be the integral there. Got my minus 1 over 9, 2 minus 3x to the power 3. Now, what is the derivative of minus 3x? The derivative of minus 3x is minus 3. Just like what I did. It's the same thing what I'm going to do here. So that will be minus 3 there. So if I put a minus 3 there, I will multiply by 1 over minus 3. That's dealing with this part only. Here, well, we know we're going to integrate this one in the next step. So now, when I integrate here, I got this minus 1 over 3 times minus 1 over 9. You need to multiply these two. That gives you 1 over 27. And this becomes 2 minus 3x. 3 plus 1 will give you 4 over 4. So that's integrating this here using inspection. Integrate minus 55 over 9. That's minus 55 over 9x. And let's put it as plus d. So this is your y. Alright, so now we need to substitute our value. What was our value here? When y is equal to 1, x is equal to 4. So I got 1 there. Let me just, so y is equal to 1 and x is equal to 4. Do this on a calculator. What do we get? Right, so remember, don't forget there's 1 on the left hand side, so it's going to be 1 minus, you're subtracting that and then you're adding that there. Let's see, 1 minus 7. If you want to, you can, remember this is 27 times, 1 over 27 times your 4. But you can type it out as it is, you've got the fraction button on your calculator. So then that will be a minus on this side here, and then that will be a plus 55 over 9 times 4. Because you're making d the subject of the formula there. So that will be a plus 55 over 9 times the 4 minus 9313. Am I correct then? Just double check me. Minus 9313.
I got a different answer, so I got 1,813 over 27.
1,813 over 27.
Minus.
Minus.
Yeah.
Okay, wait, let me just double check this here. Right, so let me just tell you what I'm doing here. So all I'm going to do here is, what am I actually typing out there? I need to make d the subject of the formula. So what do I have there? So that's going to be 1 minus 1 over 27 times your 2 minus 12 there. 3 times 4 is 12 to the power. Oh, I think I forgot to put the 4 in my calculator. I realize that now. I forgot to put my exponent 4. So if I subtract that and then I need to add 55 over 9 times 4, and that's equal to d. Let me just redo this here. 1 minus 1 over 27 times. Yeah, I forgot to put my 4 there and divide by 4 also. Plus 55 over 9 times 4. What you said? Minus
1,800.
Yeah, your answer is correct. Okay, your answer was correct. So that's minus 1813 over 27. Okay. So now, that is the final answer and that is sorted. Remember, it's a different technique, but it's still 100% correct.
Even though the
Even though your C and D are different, the fact is it's written differently, but it's still correct.